The terminal. It has been sitting there since 1978, blinking at every developer who has ever written code. Unchanged, uncharged, essentially unimproved. Zach Lloyd, former principal engineer at Google Sheets, looked at that blinking cursor and saw something everyone else had missed. The most used developer tool in the world had no business model. And that meant it had no one investing in making it dramatically better. This is the story of Warp. And it's a story about what happens when someone finally treats the terminal like a product. Before we get into how, let's establish what. $73 million raised, 700,000 active developers, $1 million of ARR added every 5 to 6 days by early 2026. That is the revenue up 19 times in a single year. And here's the number that makes all of those interesting. Zero. $0 spent on marketing. Every single one of those developers found Warp through other developers. But to understand why that's possible, you need to understand just how frozen the terminal was. The last paradigm shift was 1978, the VT 100. Everything since then has been cosmetic. The terminal didn't stagnate because it was bad. It stagnated because it was free. And when a tool is free, it attracts enthusiasts, not investment. There's a critical difference between the two. Developers pay for their tools. That is not controversial. JetBrains charges nearly $800 a year per developer. GitHub Copilot 190, Linear 192. But the terminal, free. Every option, always. The reason is not that terminals aren't valuable. Developers use them for hours every day. The reason is that the terminal was born inside Unix, bundled with every operating system, maintained by volunteer communities. Nobody had a commercial incentive to make it dramatically better. No switching costs, no product identity. A culture that treated .file configuration as a virtue rather than a symptom. The terminal was trapped in its own utility. To be fair, people tried. iTerm 2 in 2009 gave you tabs and split panes. Hyper in 2016 gave you JavaScript plugins. Oh My Z Shell gave you thousands of themes. But here is what every single one of them kept: the raw text stream, output as undifferentiated characters. No structure, no addressability, same XTerm protocol from 1978. Better wallpaper on the same broken house. Warp was the first project to question the house itself. Zach Lloyd spent 7 years at Google building Google Sheets. He led the real-time collaboration architecture for the Google Docs suite, a product now used by about a billion people a month. He understood something about commodities. Word processing was free with Office and every operating system. Google Docs turned it into $100 billion business by actually investing in the experience. Superhuman did the same thing with email. Email has been free forever. Superhuman charges $30 a month and people pay it. Zach looked at the terminal and saw the same pattern one more time. A commodity tool used by tens of millions of professional people every day with no one seriously trying to build a business around making it dramatically better. That was the gap. That was Warp's founding thesis. Seeing the opportunity is one thing, deciding how to build is another. Warp made 4 product decisions in its first 2 years: 3 that created a real product, and 1 that nearly destroyed trust before they had any users. Now, Look at the size of what was sitting there uncaptured. JetBrains $800 per developer per year, GitHub Copilot 190, Linear 192. Developers are the most willing to pay professional group in the world for tools that change how they work. The terminal sits at the intersection of all of them. Every developer, every day, multiple hours, $0. The prior slide explained why that happened structurally. Unix heritage, volunteer communities, no commercial owner. This slide is about what that means as a business opportunity. Tens of millions of professional users, maximum daily engagement, and a floor price of zero. If you could make the terminal genuinely 10 times better, you would not need to convince developers to pay for software. You would need to make something worth paying for. That was Warp's entire commercial thesis. The second was the hardest. Rust and Apple's Metal Graphics API instead of Electron. Electron is how almost every developer tool gets built. And for a PM, it's the obvious choice. It ships in months, works on every platform out of the box, and has a massive ecosystem. VS Code, Slack, Figma, before they went native, all Electron. The trade-off that's easy to underestimate. Electron apps are running a full browser engine underneath the surface. They consume hundreds of megabytes at idle and take seconds to start. For a productivity app, that is fine. For a terminal where speed is the entire value proposition, every millisecond of lag is the product contradicting itself. Warp chose to build natively in Rust with GPU accelerated rendering via Metal. That decision cost them 2 years of pure infrastructure work before they had a single user facing feature. But it meant the terminal was genuinely, viscerally faster than anything else. When you're trying to convince developers used to free tools to pay for a terminal, performance isn't a nice to have, it is the product. The third bet was blocks, and this one is the most architecturally important. Every terminal in existence treats output as a text stream. Characters come out, they scroll up, they disappear. You can't select a specific command's output in isolation. You can't address a specific error and ask AI to fix it. You can't share a specific block of output with a teammate. It is one undifferentiated scroll. Warp made output structural. Every command and its output is a discrete block, selectable, addressable, shareable, and actionable. You can click on an error block and get AI suggestions without copying anything into ChatGPT. You can share a specific block directly with a teammate. This sounds like a UX improvement. It's actually an architectural decision that makes every future AI feature possible. You cannot build intelligent tooling on top of a text stream. You need structure first. The fourth decision nearly killed Warp before it launched. Warp required a login account from day one. For a terminal, the developer community erupted. Expressed concern over Warp emitting on-device metrics to segment without prior notice. Enterprise teams said flatly, we can't install tools that require a Warp account on production servers. Here's the thing. The business logic was completely sound. AI features require server-side inference. You can't run that locally. Inference requires user identity for rate limiting and billing. Identity enables Warp Drive sharing across teams. Team sharing is where enterprise money lives. The chain of logic is unbroken, but the cost was real. Warp lost users who would never have left item to otherwise and created a trust deficit with enterprises that are still working to close. which is a big part of why they open sourced the client in 2026. We will get to that later. 0 to 700,000 developers, despite the account requirement, despite the community backlash, despite being macOS only for years. The product was simply better enough that people accepted the friction, and that is the strongest signal a PM can get. Users adopting a product that makes them uncomfortable means the core value is extraordinary. But adoption is one thing, retention and expansion are another. 700,000 individual developers using a free tier is not a business. The next question was, how do you turn a community of users into a company? Warp had a paradox. The account wall created a trust problem, but the account wall also created the foundation for a trust asset because now every user had a persistent identity, which meant features could build on top of that identity. The question was what to build. Warp Drive is the feature that transforms the account requirement from a liability into a value proposition. Here's the concept. Instead of your commands living in your personal shell history, ephemeral, unsearchable, gone when you leave the company, they live in the cloud, named, parameterized, and shareable with your team. Onboarding a new engineer runs only one command, setup local dev, and the environment provisions itself. Incident response, the on-call engineer runs a named playbook with parameters, the right sequence every time. But the subtlest use case is institutional memory. Every team has knowledge that lives only in one engineer's shell history. The deploy sequence only they know. The config command that took 3 years to figure out. The rollback step that's never in the docs. Warp drive is where that knowledge becomes team infrastructure, and when the engineer leaves, the command stays. The rule in developer marketing is that you can't manufacture credibility. The community smells inauthentic from a mile away. The only way to get a developer to advocate for your tool is to build something that they genuinely want to advocate for, which is why these numbers matter not for their size but for their origin. 63,000 GitHub stars, 100,000 WARP University views, campus programs, a CEO who does public live streams where he actually writes code, zero ad spend. Every one of those users arrived through credibility and not budget. The flywheel here is elegant. A developer switches to WARP, discovers it genuinely better, and shares a WARP drive workflow with the team. The team has to install WARP to access the shared workflow, and that's the viral mechanism. The team starts YouTube and Twitter. New developers discover Warp through that content. Loop repeats. No marketing team is needed when the product itself is the distribution mechanism. Warp's ICP evolved in 3 stages, and each stage required the previous one to exist. Individual developers came first, attracted by the performance, the blocks paradigm, the AI commands. They pay $0 to $20 a month, and they are the community that built the brand. Engineering teams came second. The value proposition shifts entirely. It's not about personal productivity anymore. It is about onboarding speed, shared incident playbooks, consistent environments across the team. That is where the $50 per seat number comes from. Enterprise is stage 3, and it is where the real money is, but it's gated by trust. Enterprise security teams have a simple rule: terminal commands, environment variables, and deployment credentials don't leave a perimeter. Full stop. Warp's answer so far is open sourcing the code and building OZ, their AI orchestration layer that runs the full development pipeline. But code transparency and a cloud hosted service are different from what enterprise actually needs. A supported, auditable, on premises deployment with SLAs. That gap is the gate between where Warp is and where the revenue curve goes vertical. We'll get onto Oz proper in the next step and into why the gap matters in the one after that. What warp promises is not equal to what enterprise security requires. That gap isn't a sales problem, it's an architecture problem. Warp's value comes from the cloud. AI inference, drive sync, agent memory, all of it flows through Warp's infrastructure. Remove the cloud, and you remove what makes Warp different. Enterprise security requires the opposite direction. A regulated bank or a defense contractor doesn't categorically distrust warp. They have policies that don't allow terminal commands, environment variables, and the deployment credentials to leave the perimeter. Full stop. Open sourcing the client and OS addresses the code transparency problem. It doesn't close the architecture gap. The enterprise blocker isn't we don't trust the code. It is we don't want the data leaving our perimeter. Those are different problems, and only one of them has been solved. The same cloud architecture that made the community possible, the same decisions that enabled drive, AI inference, team sharing is precisely what creates friction with the buyers who have the biggest budgets. Commands that transit warps infrastructure, enterprise security policies that block cloud terminals categorically, and then the world changed. GitHub Copilot launched. Every IDE started using and adding AI. The terminal was suddenly the least evolved surface in a landscape moving fast. Warp had to decide, is AI a threat to the terminal or an accelerant? The conventional fear in 2023 was that AI coding tools would make the terminal irrelevant. Why type commands when an AI could write the code for you? Warp's thesis was the opposite, and understanding why it's opposite is the most important insight in the teardown. Zach Lott has a framework for how AI coding evolves in three phases. Phase one was autocomplete. GitHub Copilot suggesting the next line. The human still writes code. The AI just makes individual expressions faster. That phase is essentially over. Phase two is the agentic IDE, cursor, windsurf, AI writing entire files and pull requests, taking multi-step actions inside an editor. The human now specifies rather than writes. We are in the middle of this phase right now. Phase three is the software factory, AI managing multiple agents across the full development lifecycle, triage through monitoring, with the human providing only intent, not requirement documents, not technical specs, only intent. This is where Warp is building. And here's the critical structural point. In phase three, the editor matters less. The orchestration layer, whatever manages the agents, tracks a state through runs, and holds the context of a code base is the important service, and that is the Warp's bet. Coding is nearly solved. The hard problem was never syntax, it was knowing what to build. As code generation commoditizes, the bottleneck shifts entirely to intent, the human ability to specify clearly and precisely what the software should do. Human intent arrives as language. To become machine action, that language has to pass through the terminal. And that is not incidental, it is structural. The terminal is precisely where human language becomes machine execution, the intent to action interface. So, as AI makes coding cheaper, the terminal doesn't get less important. The value of the layer where intent meets execution compounds. What's thesis is that AI makes the terminal the most important surface in software. Three levels of autonomy on one platform. First, ask. You type what you want in natural language. Verb translates to the correct shell command. No man pages, no Stack Overflow. Available on every tier. Act. Agent mode takes multi-step actions. Debug this error, set up this device, run and fix this test suite. You initiate, it executes end-to-end without your hand on every step. Third, run. OS. Background agents that operate without a human in the loop. connected to any data source or tool via MCP. An Oz agent can triage GitHub issues, open PRs, ping Slack on completion, and run on a schedule. You set the intent, Oz runs the factory. The depth is the moat. Competitors can copy ask. It is one model call. Run requires years of context accumulation, MCP integrations baked in, and memory that compounds across agent runs. That does not come from a feature sprint. April 28, 2026. Warp open sources everything. The client under AGPL, Oz under MIT, and this is a carefully constructed strategic move, not a pivot. Three reasons why now and why this way. First, trust is the enterprise gate. Open sourcing the client lets anyone audit the code. No hidden telemetry, no surprise network calls. That directly addresses the segment controversy and the enterprise security concern about the client. Second, distribution wheel. Open source developers contribute, promote, and deploy Warp at their companies. The community that audited Warp for bad behavior becomes the community that advocates for it. Third, Oz is also open, MIT license, but code and managed service are different things. Running Oz at enterprise scale requires Warp's cloud infrastructure, their managed deployment, their SLAs. The code being public builds trust. The managed service is how they charge. Open, what drives adoption? Charge for what people don't want to run themselves. Three layers of AI, MCP connectivity, and an open source client that drives distribution into the communities and companies where Oz will eventually sell. But there is a credibility test that every platform thesis has to pass. Does it actually work in production? Claiming the terminal orchestrates software factories is easy. Having a customer running it in production at scale on real software is a different conversation. Warp has that customer, and what they've built with it clarifies what the software factory actually means for engineers and specifically for PMs. What does a software factory actually look like at the product level? Not as a concept, not as a pitch, as a thing that runs, produces output, and changes how teams are structured. A software factory is a seven-stage loop: triage, spec, implement, review, verify, ship, monitor. Of those seven stages, one requires a human specification. Everything else, every other stage in the loop, an agent can perform. Every stage except spec runs with a human in the loop. An agent classifies your GitHub issues. Another writes the code against them. Another checks it, another ships it. The factory doesn't wait for stand up. It processes continuously from triage to production. The person who writes good specs owns the factory output. The person is called the PM. Warp 2.0 reframes the product as an agentic development environment, not just a terminal, but the operating layer for AI native software development. Three tiers of product, three tiers of pricing. The terminal layer is open source and free. You get the Rust powered GPU accelerated terminal, blocks, warp drive, and basic AI assistance. 75 credits on the free tier, $20 a month for build with 1500 credits. Now, the orchestration layer, Oz. It is MIT open source, but the managed cloud service sits at the business and enterprise tiers. $50 per user per month. For business, enterprise pricing is custom because enterprise is where Oz's full orchestration power begins. The pricing model is a usage based AI credits. This is important. As Oz does more work for a customer, they consume more credits, and Warp's revenue scales with the value delivered. In a software factory that runs continuously, there's a recurring revenue engine that grows with every PR OZ merges. Rectangle Health, a healthcare payments company. They have an AI teammate named Rex running on Warp Oz. contributing 35,000 lines of code per week, not in a demo, not in a pilot, in production on real software every week. What changed when Rex joined? Engineers shifted to specification, review, and architectural decisions. Rex handled implementation, routine tests, and standard PRs. The Oz pipelines connect to GitHub, Jira, and their CI/CD system via MCP. Rex knows what the tickets say, can write code against them, open PRs, respond for review comments. And here's the PM implication. Rex runs on specs that humans write, the rate limiting constraint on how much good software gets produced. Specification quality is the new engineering velocity metric. Here's the detail that signals genuine conviction rather than marketing. Warp uses Oz to manage its own open source contributions. When the client was open sourced in April 2026, the volume of community GitHub issues increased substantially. Instead of hiring a team of developer relation engineers to triage them, Warp pointed Oz at the issue tracker. A community member opens an issue, Oz triages it, classifies it, assigns priority, decides whether it needs a human or a fix. If it needs a fix, an Oz agent opens a PR, a Warp engineer reviews and merges. That isn't a demo environment. It's Warp actual operating model for open source maintenance. That means every issue filed against the Warp client is product qualifying Oz in production conditions. The strongest argument you can make for a platform is that you run your own business on it. Warp is making that argument. 35,000 lines of code per week from an AI teammate running on a terminal product through an orchestration layer that's now open to the world. The factory bet is real. It is in production and it is scaling. But a compelling thesis and production customer does not guarantee a win. The question is whether Warp can compound fast enough before the surface they are defending gets attacked from angles that have nothing to do with building a better terminal. The vision is done. Now, the honest accounting. Three gaps, none fatal, but all have clocks. SSH parity. Blocks in AI are extraordinary on a local machine. The moment you are on a remote server where serious infrastructure work actually happens, you're back to a conventional terminal. Real daily limitation for backend engineers. Enterprise trust. Oz is MIT open source, which matters. But code transparency and managed on-prem deployment are different products. Enterprises need supported, audited, SLA-backed infrastructure. That does not exist yet. Credit friction. 75 free credit runs out mid-workflow. Usage-based pricing creates unpredictable bills, which enterprise procurement is architecturally designed to reject. Time and capital required. The window is not infinite. Cursor and Warp are racing towards the same price from opposite ends. Cursor has an editor, agent mode, terminal. Warp, a terminal, agent mode, editor, both converging on full prompt to production ownership. But this isn't a feature race, it's a cultural bet. Cursor wins editor first developers, Warp wins terminal first ones. The real question, which identity survives when AI agents make the distinction between writing code and running code meaningless? Here's the take missing from most Warp coverage. The real competition isn't Cursor, it is GitHub Actions. Actions already runs every PR, every deploy, every scheduled job. 20,000 integrations, no human in the loop. This is structurally identical to a software factory. It just does not have AI UX yet. Microsoft owns GitHub and has exclusive cloud rights to OpenAI's models. If they ship Oz equivalent orchestration, Warp's enterprise story gets structurally harder, not because it would be better, but because Actions is already deployed everywhere, already trusted, already inside the perimeter. Warp's only defense is speed. Compound Oz's memory so fast, embed so deeply in the workflows that switching costs become prohibitive before GitHub wakes up. That race has a clock. The moat is not Rust. It isn't blocks. It isn't even the current version of Oz. The moat is memory. Every agent run teaches Oz about the code base, naming conventions, deployment patterns, the infrastructure quirks no one documented. That context compounds. Switching away doesn't mean losing a feature set. It means losing institutional memory the age has been absorbing for months. And if agents handle everything except specification, that is the PM's job now. Not the roadmap slide, not the PRE template, the precise, unambiguous, machine executable description of what the software should do. The person best at that owns the factory's output. Warp's bet. The intent layer compounds faster than the execution layer commoditizes. Right. The terminal becomes the most important surface in software. Wrong. Execution gets cheap everywhere and the terminal is just one entry point among many. Next linear or next item two. And that is Warp, a terminal company that's actually building an operating system for how software gets made. Bet on native performance, structured output, cloud identity, community trust, AI orchestration, and the thesis that intent is the bottleneck when coding is solved.